Okay, my name's Andrew Kiggins. I'm a security solutions architect with AWS. I focus on networking type, things like DDoS and WAF. I've also got wide experience in some other security areas. Worked in security for a long time. And what I want to cover today is one of the aspects of security that's really, really important. Security is basically job one for Amazon and AWS. As you can imagine, because of the business we're in, because of the number of customers we have, because of the assets and the importance, we take security very, very seriously. And how and who and what is accessed in AWS is really, really important. So what I'd like to get out of this session for you all to take away with is three things. The mechanisms of accessing AWS. Who can access AWS and how that's controlled? And then thirdly, how do we know what's going on? Who's actually accessing the resources, the applications, the services? How can we audit that for compliance? How can we audit it for operational purposes or troubleshooting? And if you were in the session before, Bill talked about the shared security model, and that's something that's going to come up very regularly in the security discussion, because what that talks about is the responsibilities that AWS has and the responsibilities that the customers have. And from a networking standpoint, it's really good because what that means is AWS is going to handle the physical aspects of networking security. We've got 11 regions, probably 12, 13, 14 by the end of the year. It's more on the way. Each of those regions has multiple AZs, which consist of data centers, which you'll never find because they're not marked, that have very, very stringent access requirements. So you don't have to worry about somebody running and putting a patch panel into a router or physically being able to get their hands on your infrastructure hardware. I was lucky enough to be in a data center, and it's very, very hard to get in, even for Amazon employees. Unless you have a very specific need, you can't get in there. So I want to talk about some other aspects of security in the network. And one of the good things about AWS is that we put a lot of tools into your hands that allow you to configure and control access to your applications and your services. A lot of it's based around VPCs and the things that brings to the table, but there's other things as well. There's other services and features that you can take advantage of. So everything kind of starts with a VPC. For the long time AWS user, that wasn't always the case. We have a thing called classic mode, which we're moving away from. Please don't use it. Use VPCs. They bring a great number of tools with them. So this is something I set up. This is my Build a Beer application. I really hope that one of the takeaways is that someone will actually go and build a way in the cloud of brewing and delivering beer. And if I can figure out how to do it, I will do it myself. I'm just not quite there yet. Very simple dashboard. When you launch a VPC, it comes up very, very constrained. You can't do a whole lot with it, and that's by design. You don't want to bring up your first application and find out there's a whole bunch of security holes, and your first job is to go and fill all those holes. So a VPC is locked down very tightly. Part of that, and a big part of that, is the use of security groups. And the way to think about security groups is a stateful firewall. That's essentially the functionality it has. And that default security group that comes with the VPC allows you to do very, very little. So the first thing you have to do is start poking some holes in that firewall. Here, I've taken a very simple web server type application. The first couple of holes I poked are 18443 for secure connections and just regular HTTP. Obviously, you specify the protocol. I don't think there's many people run HTTP over UDP, although there are some cases. So it's TCP type traffic that I've enabled. And the first thing once you get that security inside your VPC, you'll notice is I can now order beer. I can send a get beer request, and it'll go right through my VPC. It's writing inside a TCP protocol, and then it's HTTP. There are a lot of exploits that use other ports and other holes. There's many toolkits out there that can run across a host operating system, identify which ports are open. So if someone has inadvertently spun up an AMI and they left some protocols running, or they've turned them on and not turned them off, that could be a potential exploit. Security groups can control that. In this case, someone tries to run a buffer overrun on an NTP application. It doesn't even get as far as any instances inside that security group. So your security operations team can deploy security groups that stop that sort of activity. Now, it may be that in general you want to give everybody beer or serve everybody application, but there's potentially people you don't want to serve beer. For example, this gentleman here, long-time user of Romulan Ale, but maybe he's misbehaving, maybe he's kicked out a few bars. And one thing we can do at a lower layer is use network ACLs. Think of a network ACL in terms of networking as the access control list you might put on a Juniper or a Cisco router to control what's coming in and out your network. NACLs are the very same. They're implemented in a slightly different place in the network, but the outcome is the same. And what this means is I can get very fine-grained control over what's coming in. Now, the difference between security groups and NACLs is that NACLs are stateless. They don't care whether there was an outbound connection. They're simply going to stop whatever you tell them or allow whatever you tell them. By default, security groups are going to deny all the traffic, so you have to poke holes in. Network ACLs are off by default, so you have to explicitly turn those on. And in this case, what we've done is picked out a very specific IP address, and we've denied it. Now, the other thing to notice about this is that they're processed in sequence, so first match wins. In this case, that deny is going to be first for this character here. Anything after that is going to be allow. And that deny is a kind of catch-all, but it won't actually be executed because that allow would actually match everything first. So when he tries to get beer, the source port's identified and it's dropped. And these rules can be written in any of the 5 tuple, the source, destination, IP, port, protocol. It's quite a heavy hammer, but if used very surgically, it can be very effective. One of the other strategies that's important is thinking about defense in depth when we want to restrict access. The attackers will use many ways to try and get in. So actually using multiple layers of defenses in denying access is really important. And one of the things we can do when we want to control access, especially for things like HTTP traffic, is use a content delivery network. And what this does, when we create an origin, like an ELB, and we put a CDN in front of it, we make a connection between the content that's being delivered and the origin where it's coming from. We can then use Route 53. Oops. We can use Route 53. There we go. Now we can use Route 53. And what this configuration is saying is, for your www.buildabeer.com, go to the CloudFront distribution. What that means is that the users can no longer find the access point to the ELB. Everything's going to be funneled through the content distribution network. So you effectively obfuscate those back-end resources that you want to deny access to. And you force any kind of resolution from your DNS provider to point to your content delivery network. This is, oh great, can we back up? There we go, thank you. So this is from a little bit of a Twitterverse competition they were having just before Christmas last year. And there was a little bit of a fight going on out in the Twitterverse about someone threatening to take down someone else's servers. And the servers in question were Minecraft servers, which is a very popular game. A lot of people use it, and when somebody gets upset, they go after the Minecraft server, and it's the script kiddies, and it's a bit of a disaster. The really sick thing, in my opinion, is they tend to do this on Christmas Day when all the kids are rolling out their computers. However, in this particular scenario, those Minecraft servers had been placed behind CloudFront. So the attackers went looking for the IP address, and the only address they could get back was a CloudFront address, because the actual servers were sitting behind CloudFront, and they weren't able to figure out what the real IP address are. Now, if they'd been smart, there is actually a way to do this. Basically, what you want to do is an AngeRun, and this is a technique that the hackers sometimes use. There we go. So I do my resolution, I get about www.foo.com, and that points me at CloudFront. But content delivery networks commonly serve web traffic. So if I go and look for the mail server, or the FTP server, or the NTP server, whatever it happens to be, very commonly, they'll be located on the same server, and that DNS address will point exactly to the origin I want to attack, so I could find it that way. So, best practice, separate them out. Now, this isn't particularly to do with access control either. It's just simply best practice, because it reduces the potential for impact across multiple applications that you might serve. If, for example, somebody rolls out some bad software onto one particular application, takes down a host, then you don't want that crater to encompass all the applications that are potentially running on those servers. So, one application, one set of endpoints. This is just simply how you do it. It's not hard. You simply do a DNS lookup. In this case, it's the website, and you get the CloudFront address back. If you do it in the FTP server, you get the LB address back. So yeah, it's not hard. You know, it's just something you should really not let them do. Many traffic types can't use a CDN. And if you're in the presentation previously with Bill, he talked about our marketplace. There's many vendors who have excellent products in our marketplace that handle many other types of protocols and inspection mechanisms and access controls, which can be used either straight up as the front end or in a ELB sandwich with front end ELBs, back end ELBs, IPSs, IDSs, WAF devices, firewalls, new generation firewalls. There's really a plethora of really, really good devices and really good products out there that you can take advantage of. Obviously, you need to figure out what your use case is, which one fits you best. Are they auto-scaling? Do they have the right feature set? That's a touch of in the cloud rather than of the cloud. The other aspect we haven't touched on is subnets. Here, in this diagram, I've shown a private subnet and public subnet. Now, the public subnet have public-facing IP addresses. They're reachable. If something doesn't need to be reachable, put it in a private subnet. They're simply not routable. It's a non-routable address. They can't be reached, and therefore they can't be accessed. Wouldn't it be nice if we could just open up access to everybody and say, right, we've hired all the best employees, we know all our users, we trust everybody. Unfortunately, that's just not the case, and it's not because it's malicious. People make mistakes, they do the wrong thing. That's one of the issues around having humans involved. We'd really love to have everything automated so that computers could really make a mess of it. But it's just something we don't want. So best practices is really to try and screw down the access that we can get. And ideally, what you want to see is minimum access rights for the minimum amount of time. So we're going to talk a little bit about who can do that. Now, the access point, there's 3 main access points to AWS services. There's a command line. You can pull down the command line library, launch your Linux, log in, manipulate it. Very handy for doing one-off things or scripting. The second is the API. You can download the SDKs, Python, Ruby, Java. This little script simply is a very short script that allows you to go and grab all the EC2 instances that you have running. And of course, there's the management console where you can go through individually. It's the graphical user one we're all familiar with. It's very visually friendly, point and click. And then there's all the methods that allow us to use those. There's credentials, certificates that allow us to access those. So we have to think, how are they controlled? How do we control those access points? How can we control who has access, what their privileges are, and what are the policies associated with them? So at the top level, there's the accounts. That's your 12-digit account number, godlike powers. Underneath that, we've got users, typically associated with a person or a role, although in this context, roles are slightly different. And users come in 2 flavors. There's IAM users, which we define internally, or you can have federated users. We'll talk a little bit about federation later on. That's for associating with other systems. And then groups, you can associate privileges with groups and then put users or roles into groups. And then there's whoops, I don't know, I think there's too many buttons in this thing. There's roles. Roles are a way of controlling policies, and users can adopt a role and then give it up. You can give out roles for a certain period of time, make them token, time-based, allowing much more granular control. And then services. It's not always a person that's doing something in the system. Maybe you've got an EC2 instance that's doing something in the system, running up a database, enabling some loggings. Similarly, those services can have policies associated with them. So now, I know it's after lunch. Oh, here we go. Let me try that one. This one, good, thanks. Okay, so this is on the test. If you take nothing else away from today, get this. So we talked about how many people are secure. Look, I don't know, how many are there? There's maybe 100, 120 people in the room. Okay. I read an article earlier on. Basically what it said was, if you take the top 5,000 passwords and you throw them at a given system, you will get 1% hit rate on the first attempt. That means that in this audience, there's probably 8 to 10 people who use the password 12345678. Now, given how many security hands went up, I'm sure that's not the password you use. But enforcing password rotation, password strength, number of characters, there's 26 letters in the alphabet. That really reduces the number of combinations. If you enforce the whole ASCII character set, you've got 256. So enforcing long passwords. Don't use dictionaries. I think that the next one was, I love you. Really? Because nobody can think of that. It's not, and then things like dictionary attacks, right? How many people have got a dog named Rover? And unfortunately, it's not that people are stupid. It's not that they can't learn. It's just they're a bit lazy. They want something they can remember easier. The actual article I was talking about there was done in 2010. There was a follow-up in 2015, and the results were almost identical, which doesn't mean that we haven't seen these things. We all know that people have been hacked. So enable strong password, enforce strong password, because people don't do it themselves. Whoopla, I messed that up. Can I go back? No. The other one I want to talk about is the root account. Do not use the root account. When I first joined AWS, I went through the best practices. I set up my own little account. And first thing it says is, don't use root credentials. That makes sense to me. Delete. Read down the page. You can't get your root credentials back. Okay, so I read that first. The thing about that is, it's actually not a really big issue, because I've never needed my root credentials, because I did have an admin account. And everything I've done since, I've used the admin account. The root credentials should be the break glass. You know, someone has stolen my credentials for one of my users, and I need to kill that user immediately. You know, somehow my passwords have got out. In reality, what I learned was I really didn't need them anyways. So long as you've got your admin set up, just don't use them. If they get out there, and they have been on GitHub, not mine, obviously, because I deleted mine. We have seen instances where people have coded it in, put them in GitHub, get a big panic. The reason is AWS does not look at your information. It doesn't want your information. But the flip side of that is the responsibilities on the customer to protect it. So write it down on a piece of paper, put it in the safe, and forget about it until you have to do that break glass, because we really can't get them back. So we're going to talk about policies. So moving on to policies and how you use policies. I don't know if we can get that. Policies are used to control who gets in, what they can do once they're in. And there's two kinds of policies. There's managed policies and there's inline policies. Now previously, there was only inline policies. Inline policies are attached to a particular user or a particular resource. They control it. The problem with that is it's not scalable, or you have to do a lot of gymnastics to make it scalable. So every single user has their set of policies. Every set of resources has their policies. So we came up with managed policies, and managed policies have a couple of flavors. There's the managed policies that you get by default from AWS, things like EC2 All Access, or EC2 Launch, or RDS Write, RDS Read. And they're canned policies. You select them from a pop-down. You can apply them to a user, or a role, or a group. Very easy. Of course, to make it usable, there's also managed policies that you can develop yourself, depending on your business, depending on your application or your use case, that give you much, much finer control over what you can do. And you can overlay these policies. You can have multiple policies. I want Joe to be able to manage my EC2 instances and my S3 buckets, but he's not able to use CloudTrail, or he's not allowed to use Inspector. Some people might only have read access or write access. Maybe certain users can only set up logs to write into certain buckets, and admin have read-only access. So definitely using managed policies is the path of least resistance and best practices. Now at least I've figured out this new one. Now, IAM's great. It's been around for a long time. Everybody understands how it's used. But there are downsides. With IAM, you get very, very fine-grained control. But at a certain cutover point, scalability starts to become an issue. So at that point, you start thinking about other ways to manage your identities and your access. There's another reason for looking at it that way. Many companies are moving to AWS. They're not starting on AWS from scratch. For a startup, IAM is great. You've got 4 guys sitting in a garage, each has got an account, and they're off to the races. If you're moving to AWS, typically you already have large infrastructure. You've got your own system of managing your identities and your access. And to enable that, we've got services like AD Connector, which will interconnect with any SAML-enabled service and allow federation to those already defined users and groups and roles. At the very far end of the spectrum, we've also got customers who've completely rolled their own. I was at a customer a few weeks ago, and they were describing what they've done, and it was absolutely outstanding. Basically, they don't have any roles, and they don't have any policies. They've actually built a system which, on the fly, pulls the information from the database, creates a policy, puts a time limit on it, grants access to a user, allows them to do that one thing, and then deletes it. So it's very, very impressive that they've got such fine-grained controlled in an automatic way, but of course, there's an upfront investment. And this is one where Amazon actually eats its own dog food very, very enthusiastically. We have our own custom identity broker that we use internally. There's pages where if I want to use my account, I log into the web page, I click the link throws me into the console, automatically signs me in. So, but that's at the very far end of the spectrum, where you've got ops teams and development teams that can spend the time. The big benefit of that is you have the control and the automation. For simpler things, we've got things like Amazon Directory Service. You can launch an AD inside AWS and use that off the bat. So there's a wide spectrum of things. Down at the bottom there, there's actually a really good presentation from reInvent last year that walks through all these options and how they're used. Of course, that's all well and good. It's really important that you've figured out how people are getting into your systems, you've figured out who they are, you've constrained them by policies and by roles so that you know what they can do, but you still need to know what's going on. So even though you've set all these things up, you still have to get your logging right. And there's a number of services that are very efficient at that. They're great out of the box. I think Bill touched on these briefly, so I want to dig into them a little bit more and talk about how they can be used for visualizing and tracking, especially for auditing and compliance reasons. So CloudTrail is really good. I like CloudTrail a lot. When I first looked at CloudTrail, I was expecting, okay, what does it have to do to get this up and running? That was pretty much it. Literally, it's check a box. If you want to get really, really into it, you can also select a region, but literally, it's one click to turn it on, and then you define the regions you want it on. Why not turn it on globally? There's really no reason not to turn it on globally. There's no cost other than the S3 buckets, which you're storing your logs in. So really, really effective. The reason it's effective is that it's a low barrier to entry. It's pretty much frictionless. And as we roll out the interconnectivity with the services, and one of the big things with Amazon is we're developing a lot of services and features. Last year, there were over 700 new features and services deployed. CloudTrail is being attached to them all, and over a course of time will be available for all services. What that means is you get automatic logging of API calls that are done, and that's really, really effective. Anytime someone creates an instance, anytime someone sets a role, anytime makes a modification in your VPC, it's all going to be logged and stored and archived, which leads to some really interesting use cases. Now, one of the best practices that we know a lot of our customers are using is they'll actually create separate accounts. They'll have an account where all the productions workloads are, And then they'll have a separate logging account, and they'll use a thing called cross-account trust. And what that allows them to do is to say, in my account production, I am allowed to write something or do something in that other account. And with policies, you can say things like, let these account write into my S3 buckets, but don't let them read and don't let them modify. And what that allows you to do is have a very secure set of logs that cannot be tampered with, which is really important for auditing, logging. Anybody that's looked into some of the compliance requirements, the requirements around logging are very, very stringent. And that kind of thing can be enabled with cross-account policies, and CloudTrail's one use. So what can we do with it? There's a number of great use cases that CloudTrail enables. Obviously, historically looking back, at what people's behavior are, what's been happening in the system. What happens if something goes wrong? Was there culpability? Was there a mistake? How do you fix it? How do you make it? You have to know what happened. You need that sequence of events. Dealing with operational issues. Was there a setting wrong? When I tried to make this API call, did it succeed? Did it fail? Were there things that should have been done differently? And as I mentioned, as a compliance aid for meeting compliance requirements. Again, there's a great white paper. I don't have time to go into the details here, but there's a great white paper that goes through all the capabilities of logging. AWS config, I think Bill touched on this. This gives a very good view into what's happening in your system, what resources are being launched or deleted. You can get a time view of what's happened in the system over time in your account and or accounts. Further, you can actually tie it to a notification system, SNS or mail, so that you get notification. We've got something, one of our customers wanted to make sure that developers couldn't spin up more than 5 instances, cost control measure. Give them a sandbox that they can play in, allow them to launch instances, but just don't do more than 5. So, little Lambda script, if more than 5, send me an email. It gives a comprehensive view. Now, there's great filters here. This is just a little subset of some things I spun up. You can get pages and pages and pages if you want the global view, but you can also drill down to say, just tell me about the EC2 instance. Just tell me about this resources with these tags, so you can get a very good view of what's happened. And then over time, you can say, right, tell me the configurations that have happened with this sliding window, so you can visualize this data and find out, what my users been doing, what's been happening to my systems over time. This came out last year. Config rules, you can make things happen. Back up one. There's a bunch of pre-built rules that you can use. You can make it periodic. You can do it event-driven to say that when something happens, run these rules on it. And one of the good things is you can use it to implement security best practices. Encryption, very, very important. No reason not to use encryption on your EBS volumes, but somebody could spin one up. If they have the right privilege, they could spin up an unencrypted volume. You can write a config rule that says, when EBS volumes get spun up, go and check if they're encrypted. If they're not, encrypt them. We talked about the old classic model of deploying EC2. Really, nobody should be using EC2 Classic anymore. There's really no reason for it. So, put a rule in that says if someone tries to launch an EC2 instance without VPC, without security groups, terminate it. So these things can be done with AWS config rules and to implement your security best practices. This is just a very simple one. This one says that everything must be tagged. One of the ways you can control how instances are used. and launched is by tagging things. It allows you to do inventory based on usage. You know, maybe you've got a production, maybe you've got a staging, so you can tag things. These EC2 instances are all production instances. These are staging, these are beta. And this config role is saying, if this EC2 has not been given a tag, then I want a notification of it. So this was exciting. I don't know if you realized this morning, Amazon Inspector went GA. I don't know if you managed to make that presentation this morning, but this is great. This is an agent that can be deployed on EC2 instances to detect a large number of things. Some of those are vulnerabilities and exploits, some are configuration. From an access point of view, the interesting thing is it can be used to check things like which ports are open. You know, has someone left the telnet port open? Does the SSH daemon allow for root access? And a lot of things are canned, so by turning on Amazon Inspector, you can get a very good read on potential access holes and problems on your instances and get that fed back into your logs. I highly recommend taking a look at it. Tom Stickle did it this morning, gave a great overview of Inspector and all the capabilities, and obviously it's an ongoing development thing. There's a bunch of canned rules. From an implementation standpoint, although there's an agent which is under customer control, whether that agent's on or off, it takes a minimal amount of CPU, and the telemetry is sent to a back-end service where all the processing happens. So very low impact, but potentially a very high upside for exploit detection and security vulnerabilities. This is the rule packets. You've all heard the CVE rules and announcements where they determine the latest set of vulnerabilities, be it in libraries, be it in processes or applications that are being deployed. So these are built in. CSI for things that should be configured on the hardware. It can look at the configuration of the OS, be it Windows or Linux, and then things from AWS that we've learned are best practices, and they're all baked into the rules engine that does the analysis. Just coming back to networking, one of the things that's sometimes a bit of an issue for customers as they transition to AWS is lack of control at the access level. Now, as I mentioned, AWS is responsible for the security of the cloud, so we've got a lot of controls in place that are going to ensure that access through the networking infrastructure is highly controlled. We've got the SOC 2 report that goes into the compliance issues of that. But VPC Floor Logs is a very powerful tool that can be used. And what that visualizes is the traffic flowing across the VPC. Now, it's based at the 5-tuple. It'll tell you the sources, the IP addresses, the ports of all the traffic coming in and out the network. And you can stream that out. This is a very simple one that I set up. And you can deploy it in all the enhanced network instance interfaces so that every instance can give you a snapshot of what that traffic was. This is simply what it looks like. It gives you these one line. What happened? Was the connection accepted? When it happened? What the IP tables? What the IP addresses were? And the good thing about that is that you can make that into a stream and send that to CloudWatch Matrix and then graph that metric. So you can look for strange types of access, like a denial of service attack. If there's a sudden big uptick that's not a flash crowd that you're expecting, you can get graphical representation of that. You can connect it to alarms that said, if I get too much traffic or over a certain threshold, I want to be notified. The other thing you can do is you can actually go and log dive. This is a very simple Python script, and all it does is go and trawl the logs and pull out the source IPs. So I can tell very quickly which IPs are hitting my service from a top talker. So now, this is a very simple, it just does a single pass, but you could obviously run multiple algorithms on this, pulling out time of day, looking for diurnal patterns. And what it allows you to do is detect strange access patterns. It's actually a technique that we use in denial of service. We continually monitor what source IP addresses are coming through our edge locations, and we run algorithms to look for anomalous types of traffic, source IP addresses that we don't expect, or sudden changes in user patches. So flow logs enables that kind of behavior. It makes the data available to you for all kinds of processing. And of course, there's companies that are very, very good at handling logs. I was speaking to the Alert Logic guys out there. But Sumo Logic, Splunk, Trend Micro, they've all got really excellent systems that do a very good job of pulling logs from all sorts of different locations and allowing for correlation. Some of the the very cool things you can do is start correlating events. I saw a very large DDoS here, and then strangely I saw some kind of scanning activity over in these instances. That's one of the things we've seen in DDoS attacks, that the DDoS attacks now are simply a shield for something else. So traditionally, when your operation or your security operations were looking at this DDoS attack, maybe they weren't looking at any kind of infiltration attempts. So a lot of these products do that kind of correlation. Obviously, there's a certain amount of configuration you would have to do. These things automatically ingest a lot of the AWS logs, but being able to feed system logs in from your servers, tuning them so that they're exporting the right data, allows you to give a very, very strong picture of what's actually happening in your system, what kind of traffic's coming in at the network layer, and what your users are doing. And with that, I conclude. So thank you very much for your time. I hope you've learned something. I hope it's been useful. I'm available for question and answer. And don't forget to complete your evaluations. That's how we know what's valuable for you, what you want to hear more of, what holes you want filled.